Hello, what's going on, everyone? Welcome back to another wonderful day of math on this beautiful day. I hope everybody had a awesome 4-day weekend. I have pretty much gone through and updated everybody's grades up to this point for fourth quarter. Hey, what's going on, Shannon? So if you guys have any questions about assignments or any missing assignments, just give me the heads up. What's going on, Tabitha? Um, but yeah, I think for the most part, if you turn in an assignment, there should be a grade in there right now. No, you guys don't have a final for this class. I will say that this particular lesson that we're doing right now, Unit 11, lesson number 11, is the last new lesson that you guys will have for my class this year. Um, we're going to do review for the next 2 weeks, and it's going to be review stuff that's kind of heavily covered within the next year for math. So I'm not going to do anything too crazy. I'm just going to keep it very brief. It's going to be stuff that we've done, and we'll just focus on that. All right. I'm just checking to see how many people are on right now, because I'm only seeing 5 people in. Oh, I don't know. 4 or 5 people are here right now, but today's just going to be going into, it's not necessarily new stuff, but it's going into word problems using sine, cosine, tangent. So it's just kind of picking up with what we've been doing. You just have to pay attention, or I should say, you should be able to draw the picture. If you guys can draw the picture, solving these word problems won't be too bad. All right. So I know there is a slight delay right now, and it's really bugging me. Let me try something. Oops. Undo. I gotta try doing one little thing and see if it fixes it. Alright, let's see. I think I'm good. No, I'm not. But whatever, I just won't look at my camera. With 90 and 180, so it's just like how we did them before. So Tabitha, remember, if you have 180 degrees, it's a unit circle. So if you're doing the unit circle, what would that coordinate be at 180 degrees? What would that coordinate be at 90 degrees? And if you're still having trouble, yeah, stop by Zoom anytime and I can help you guys out. I can draw out the picture and I can actually talk to you guys step by step with it. Number one, this word problem is going to be a little bit different than the other two that I'm going to be doing today, but I wanted to throw it on this lesson just so you guys can see an example of it. It says that this person is on a Ferris wheel and they're sitting at a distance of 45 feet from the Ferris wheel center. Yeah, that's all you'd have to do, Tabitha, or solve what the question's asking. If they're at an angle of 120 degrees when measured in standard position, how high above the center of the wheel are they to the nearest foot? So what I'm going to do, because we have an angle, I'm going to draw it. And anytime you guys see an angle, for the most part, I recommend doing a rotation. So I have my x and y axis, and I have 120 degrees. So I know 120 degrees is going to take me over into the second quadrant. So this is very similar. Everything that we're doing today is stuff that I've already taught you guys before. It's just going to be done with word problems. So we know that we're going to be up here in the second quadrant. And we just found 120 degrees. Okay. Now we're on a Ferris wheel. So what I'm going to do is I'm going to draw a circle. Okay. So it's saying, and you know what? It's going to bother me unless the circle goes to the end of that arrow right there. So I'm going to make it a little bit bigger. So that means I got to make this a little bit larger down here as well. So what they're saying here is that on this circle we have this person sitting on the Ferris wheel. And I'm just going to draw a little cart. And there's our little dude. Okay, so he's on the Ferris wheel. They want to know if the distance from the center of the Ferris wheel to that guy is 45 feet. They want to know how high above the center he is. So, all I want you guys to recognize is this is actually a problem we've been doing quite some time now. You guys recall drawing in some right triangles. So this is just a right triangle, and the question is just asking you guys to find the height. It's asking you how high is he from the center of the Ferris wheel. So in order to figure this out, we need to know the angle that's inside that right triangle. Well, if it was 120 degrees, come on, iPad, it's been freezing up even more as of late. Work. As long as it doesn't crash, I'm happy. Because then I have to draw that wonderful picture all over again. Alright, so we know this is 120 degrees. Did it just freeze again? There it goes. 120. So that means this little angle in here would have to be 60 degrees because a straight line is always 180. So I'm going to put a little 60 degrees inside here. So that means that we're working with a 30, 60, 90. Yeah, that's correct. So we know that the one side's 45. Now there's two ways you can solve this. You can turn it into a unit circle, which if that's what you guys want to do, you can. But I'm going to go back to the Silver Creek teachers and the taking oats away, that little saying that you guys have done. Because this question is asking you guys to find the height, this is telling us that they want you to find the y value. So this right here is just your y value. And we said when we are working with trig functions, the y value is also known as sine. So in this particular problem, they want you to find the height using the sine formula. So if we were to do the Silver Creek teachers, sine theta is equal to opposite over hypotenuse. So now what I'm going to do, I'm not going to change it into a unit circle. It didn't say anything about a unit circle, and that would take more steps. We're going to base it off of what we did in geometry last year. The theta is just the angle, and we already figured out that that angle was 60 degrees. So I'm just going to plug 60 in for theta. The next part, I am trying to find the opposite side. The opposite of that 60 degrees was a question mark. So we don't know what that is. I'm just going to call it x. The h stood for the hypotenuse, and we do know the hypotenuse is 45. So if I want to solve this, I have a fraction on one side of the equation, and I have sine 60 on the other. If I want to solve it, I got to make sure that I change that sine 60 into a fraction. And from here, we're just cross multiplying. And we can do this all with the calculator. So I'm just going to do sine 60 times 45, and then 1 times x is just going to be 1x. So we just have to type in sine 60 times 45. Now, make sure when you guys are in your calculator, you are checking your mode and you are making sure that you are in degrees. Because we said it was 60 degrees, your calculator has to be in that degree mode. So mine already is. Just check to make sure you guys are. And now we can just type in sine of 60 times 45. And it says that the answer is coming out to be 38.97. I don't know if I said what to round it to in this question. It said to the nearest foot. So if we're going to the nearest foot, this would be approximately 39 feet. Okay. So if you guys got any questions with that, just let me know. I only plan on doing 2 other questions with you guys today. The next ones are going to kind of tie in with the graphs that we were doing, the frequency, the period, the amplitude, and the midline. It's just in word problem form. So everything's still kind of the same as what we've been doing. We're just putting it together with real life scenarios. One of the biggest things that they use, yeah, that's fine, Sierra. One of the biggest things when you guys are talking about sine and cosine curves is high tides and low tides when it comes to the ocean. And I know we don't really have to deal with it all that much because we only have Lake Erie, so there's not really tides to Lake Erie. There are, but it's so minimal that we don't really pay attention to it. But in exercise number 2, it says the tides in a particular bay can be modeled with an equation of the form D equals A cos B of T plus C, where T represents the number of hours since high tide, and D represents the depth of water in the bay. So the maximum depth is 36, and the minimum depth is 22. And high tide hits every 12 hours. I don't know if you guys talked about tides in any of your science classes, but the tides are determined based on the sun and moon patterns. Mostly with the moon patterns, though. So high tide is normally going to occur, I believe, in. I better not say it. It just says it hits every 12 hours. So every 12 hours, the high tide's going to hit, and that means the opposite, like every 6 hours, then it should be at its lowest amount. I don't want to go too sciencey because I'll probably say something wrong, and then I'll get called out by like Janish or something. So in exercise number 2, it says determine the values of A, B, and C. And then we would have to just state the equation. So A stood for the amplitude. So the question is, did this problem ever tell us how high up we're going and how far down we're going? Not necessarily, but what it does tell us is the maximum height and the minimum height of the water. So we can use that to try and determine what the amplitude is going to be. So it said that the highest part's going to be at 36 feet. So what I'm going to do is I'm just going to create a little dashed line, and I'm going to call that 36 feet. And we also know what the minimum is because it's down at 22 feet. And I know my numbers are not going to be completely accurate, but I've done the drawing before, so I know that it's going to fit right here. So we know the water length has to be between 22 and 36. It's never going to get lower. It's never going to get higher. So in order to find the amplitude, what we really need to do is find that midline first. We have to figure out what the middle value is going to be before we can figure out how high we went and how low we went. So you can average them out to find that middle line, because if you take 36 and 22 and add them together, you're going to get 58. And when you average something, you just add them together and divide it by 2. So if I have 58 and I divide it by 2, that should give me 29. Or you guys can just count it and try to figure out what's in the middle. So I'm going to check this. I have to confirm that this is correct. If this is correct, the amplitude between the max, min, and midline should be exactly the same. Well, if you go from 29 to 36, that is going to be 7. And if you go from 22 to 29, that is also going to be 7. So the amplitude for this function is 7 feet. Because it's how high and how low you are from the midline. That being said, we can also say what the midline is right now, because the C value represents the midline. I use pink for this. So C is equal to the midline. And we found the midline by doing the average, and the average was 29 feet. The last thing we got to do is figure out what the B value is going to be. And the B value determines the frequency. Oh my gosh, this stupid iPad froze again. Just give me time. I gotta wait. Unless my pencil died again. I don't know. I don't think it died. I had it plugged in earlier. Nope, it just froze. Alright, so now when I go to do this next part, it's just going to be the frequency. So the frequency just tells us how many times that the wave is going up and down. Well, you got to remember, it said that it goes high tide every 12 hours. So if I started here at 0 and I go out to 12 hours, that means it should be at high tide. If I go another 12 hours, I'm going to be at 24. That means it's going to be at high tide again. I can go another 12 hours. If I went all the way to 36, once again, that is high tide. So I know at all of those marks, I have to be at the highest point. Now, the question is it says that it wants to know the frequency. Well, if we're saying that it hits high tide every 12 hours, think of how many hours there are in a day. Really, we only have to graph this all the way to 24. 24 is going to be the end mark because it's a 1-day period. So we need to know how many curves do we have between those points. And I probably didn't draw it out perfectly fine, but it's okay. So I know this is a cosine curve. So this cosine curve is stating that it is positive, right? Because we're saying that the amplitude is starting at 7 feet, right? So that means we have to start at high tide because it's every 12 hours is high tide. Now it's going to go down. We don't need to know what the numbers are in the middle because we're just trying to graph the scenario. So I'm going down all the way to its lowest peak, and then eventually it's going to go back up. So it's going to make it all the way to the bottom, and it's going to go all the way back up. I mean, we can label what that number is going to be right here because we know that it's every 12 hours it's at high tide. So that means half of that should be at its low tide. And it's just going to keep repeating this every single 12 hours. So now, once again, it's going to go down to its lowest mark. And then it's going to go back up. Oh no, it crashed! Why did it crash? I might have just lost that entire graph. Oh, that's the homework. Okay, I didn't lose it all. That's good. Whew. Alright, so it went down to its lowest mark. It went back up to the highest mark. That was the lowest at 6. And then it repeats. It goes all the way down to the lowest mark, all the way back up to the highest mark. And again, that's the lowest. Halfway in between 12 and 24 is going to be 18. And we can repeat this every single 12 hours. In this case, we're just looking at 24 hours because it's 1 day. So our frequency is the number of times we had the letter C, the number of cosine curves. So if we look, I had one cosine curve right here because that's one letter C. And then it repeats and does it again. So from 0 to 24, the frequency is 2. Okay, so the frequency is 2. We can figure this out by using the formula, the 2 pi over b. And we can break it down that way and we can find it that way. But I'm just showing you guys that it's just 2. So Sierra, this question right here is the same exact one that we did the other day that was called the practice trig graphing review, except now we're just putting words to it. So it's all still the same. We're still looking to find the max and min. We're still looking to find the midline. We're still looking to find the amplitude. We're just using it based off the word problem now. Before, I just told you guys the equation, and then you would go and graph it. Okay? So that's all we had to do in that question. That was it. I mean, technically, in part A, we should have wrote down the formula as well. So in the formula that we have up here, I should be writing that out. We said the A value is 7 cos. The B value is 2, and then we're using T for time. And then the C value was 29. That's the only part that I was missing, was the actual equation. So Sierra, I just want to make sure you're good with the graphing. That's the big thing that I want you to get out of this right now. If you're struggling with how the word problem is written out, it's okay, because when we finally get back to school, I can show you guys how to do these ones with a calculator. We had to skip over that lesson though, because trying to do it on the iPad is not that fun. It's much different than handheld. So if you guys plan on taking Math 12 next year or pre-calc, myself or Miss Randolph will be showing you guys how to do these with the calculator. Okay. Last one I'm going to do with you guys down here. This one is known as, I think it's talking about daylight. And it's talking about the daylight and Poughkeepsie. Oh my gosh. Yes, you're right. Yes, Tabitha, it is 1/2. It's okay. I was looking at it as 24 hours, and I forgot that the problem stated 12. I'm not going to write it down because I don't want to confuse anybody, but yes, Tabitha, you're correct based on what the question was asking. I changed it when I asked the question, or I started stating it in the graph. But in exercise number 3, the possible hours of daylight in a given day is a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight occurring on the winter solstice is equal to 9 hours, and the maximum hours of daylight occurring on the summer solstice is equal to 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? So recall what we said, what amplitude is. Now, this is a very long problem. And I just want to state, it's not asking us to find the equation. It's only asking us to find the amplitude. So we have to figure out how high above the midline and how far low below the midline this equation would be. So again, we don't need to know the actual equation. So I like doing it with pictures. A lot of you guys may be able to do this one off the top of your head. But I like doing it with pictures, so I'm going to draw a picture. I'm going to draw an X and Y axis again. Now, we don't care about the number of days that we have sunlight. We just care about how long the daylight is. So we know that the maximum number of hours of daylight, summer solstice, I believe it happens in July. I think it's late July, like July 21st. I don't know, somewhere around there. That is considered the longest amount of daylight in a single day for the entire year. And the same thing happens for the winter solstice, which is sometime in November. I think it's around that same time, November 20 or 21st. And that is the least amount of sunlight that you would get in a single day. So the max is at up here at 15 hours. And the min would be at 9 hours. So, wait, which day is your B day, Shannon? Was it the the July one or the November one? So in order to find the amplitude, we need to know what the midline is. So you got to find the midline first before you get to the amplitude. They coincide with each other. They always are together. So, oh, it's the July 21st? Okay. So in this case, the number that would be between 15 and 9 is going to be 12. Because 12 is 3 away from 15 and 3 away from 9. So the only thing they wanted to know is the amplitude, and that amplitude is going to be 3. I don't know why this iPad sucks. That's all they were asking us for this problem. That was a huge word problem. And all they were saying is, hey, if I'm giving you this range, if I'm giving you this minimum, and I'm giving you this maximum, figure out what the amplitude is. Okay? So I like those questions a little bit more because you don't have to go through and do the drawing. You're just taking the maximum and finding the midline. Okay? So tomorrow I'll do 2 more questions with you guys. One is dealing with a yo-yo, and the other one is with a swing. And I think you guys are going to prefer exercise number 5 a little bit easier because they're giving you the equation straight up. I mean, technically they both are. I think tomorrow's going to be a really short day for you guys. We might be able to finish the lesson in like maybe 10 to 15 minutes. But yeah, that's all I got for you guys today. There's only 2 questions on the homework. I mean, you guys are more than welcome to give it a shot and go through it. It's not, being that they're word problems, I only can do so much with you guys to help guide you guys through them. So take a look at them, read through, see if you can determine your amplitude, to see if you can determine your range, see if you can determine your midline. Number 1, I already gave you the equations. You might be able to do a lot of it without much help. The second one, you have to create the equation. So it's one you have it, one you have to create it. So see if you guys can try to get there. If not, you always can come to me for questions. We got the Zoom and whatnot. Once again, last lesson that we are doing for the year as far as being new. Next week, we'll still have to do lessons, but they're going to be review lessons. And then the week after is technically the final week of school. So we'll still be doing a little bit of stuff that week, but we're not going to do a lot because I want it to be more of like a makeup week. So if you're missing assignments, you can still turn them in so I can finalize the grade book. So then you guys know what your final grade is going to be for the year. So that's all I got. Definitely shoot me an email if you guys have any questions. Ella, I see you now have 2 accounts. So I don't know what happened. Maybe you forgot your password or something. But I am filling up my pool right now, so I'm going to go check to make sure that it is not overfilling because I get to go swimming tomorrow. I'm very excited. So I hope you guys are enjoying this hot spring heat. It's going to cool down this weekend. It's going to get back down into the 60s, but I'll take it. So I hope you guys have a wonderful day. I will catch you guys later. Oh, that stinks, Ella. Now you have 2. Just give me more money. Keep watching those commercials. That's all I'm saying. Keep watching those commercials. See you guys.